uh, all basic definitions of all the different sets with respect to the subsets and everything. Okay, one second. So what you're going to do along with me here is you need not write complete definitions and all. You can take notes like, which means you can just take the heading. So you can just do some small scribbling because I'm not going to give time for notes. At the same time, you need to understand what it is actually. So that's what I'm trying to do here. Okay, so we'll discuss everything in detail. First, with respect to definition of a set, actually we are not defined. We are given a colloquial definition only. We are not actually defined. So what do you mean by set? We'll go for a definition. Actual definition of a set is it's a group. That's what we discussed. It's a group which will have a common rule. That common rule will be, it should be very unique. So the members in that group will be distinct and unique members. What do you mean by this point? Probably you can understand when you say it's a group, it's bringing together or clubbing together of elements. What do you mean by distinct or unique means? Let me go for this example. Let A be the set of students in my class. Okay, set of students in my class. Okay, please listen carefully. I just want to name first student Aarti. I'm not going in alphabetical order. First student herself is Aarti here, and there is another one student Anand. Okay, there is another one student Babu. There is another one student Babita, etc. Okay, I'm not going to list everything. It takes a long space for me to write, right? For if I have like 50 students, it will take a very lengthy space for me to write. So what I'm going to do here is I'm going to cut short the name. So what I'm going to do here is I'm going to write only the first alphabets. So A is equal to A, B, B. Am I right? Up to 50th student. Okay. Now the problem arises here when I define a set here is it should be distinct and unique. When you go for the definition, it's clear that it is the name of the students in my class. Okay. So I started naming them Aarti, Anand, Babu, Babita, etc. But when I go for listing it with the help of the first alphabets alone, I get 2A repeated, 2B repeated. As per the definition of the set, this is not allowed. Actually, it's a very big limitation. When this one is given, it's fine. When this one is given, it's fine. But when the set is represented in this form, I have to write set A consists of A, B only. See, 2A's, I'll not repeat it. 2B's, I'll not repeat it. That's what I call as unique. Actually, it's a limitation. If you talk about set theory, it has a very wider application. It's useful in all the cases, probability, statistics, everything will be relied on set theory only. But when it comes for this type of a case, it's actually limitation what to do. Okay. So we'll be writing single A only, single B only, will not repeat A's and B's. Okay. So you have to remember that because it's asked in the exam. So it was like once in the exam, the question was like, see, actually, will not get the question paper. For CMA Foundation, earlier it was uh, descriptive paper. So we got the question paper. Now it is objective paper. For CA Foundation, from the beginning is objective paper. So we'll not get it. The students, what they share, no. So this is how soon after the exam, I will not wantedly call the student. Students will tell me, ma'am, you told this in the classroom and we got it. And some students, after the results only, they meet me. Then they'll be saying, ma'am, you told this one, ma'am, probably we may not be, it may not be in your syllabus. We may not be expecting that, but actually that the same question came, ma'am. So this was a question asked in one exam. It was like A, B, C, A. Is this a right set? No. It was like option A, option B, option C. It was like A, B, C. Is this the right set? Yes, because there is no 2A. Will not see, you need not know about what that A is. See, if I give only this one, okay, I'll box it. If I give only this one, you'll know what is A and A. What you know what is B and D? You will not know. You will see that it's 2A. Okay, it's repeated, unknowingly repeated. So let us write only once. If I give only the definition and the rule, you come to know, okay, it's Aarti, it's Anand. So if it is given in this form, we'll understand that this A is repeated twice. So it's not following the definition of uniqueness. So that's why we'll remove it. Okay. So this is right. And also this one question was again asked like A is equal to CBA. Is this right? Actually, we'll present in alphabetical order. Okay. If this is right or this is right, then this is only right. CBA is obviously not wrong, but which is more closer to the answer is ABC because ABC are English alphabets. Usually we write in alphabetical order. Likewise, if you go for numbers, if it is given 3, 5, 1, 7, we'll not write in this way. Instead, we'll write it as 1, 3, 5, 7. Okay, so we have to remember all these silly things, okay? But obviously, we need to get 1 mark with. We don't want to miss that 1 mark. Okay, so this is the definition. Second heading, I'll go for. I want to turn over the page. If you want to make a fast scribbling, you can just make a note of these 2 words alone. Okay, you're not going to write the full example. If you want, you can repeat watching the video and you can take notes. Okay, I'm not going to give separate time for notes because you need to focus on the concept. Okay. Next, we'll go for representation. How you represent a set. There are 2 types of representation. One is actually you list it. Okay, it's called as listing method or it's called as tabular method or this is found by Mr. Roster. That's why it's called as roster method. Set of English alphabets, set of vowels in English alphabets. A is equal to, you know, right? A, E, I, O, U. See, it's just separated by commas. Will not do anything else. Okay. Second method will define by a rule. So it's given as rule method. Because of that rule only, we'll pick the elements. It's called as rule method. Okay. Can be done with the help of algebraic expressions. So you can take it as algebraic method. Okay, the different names. Algebraic method. It's also called as set builder method or it's called as property method or it's called as selection method. See, we have so many terms, alternate terms. You can call this as rule method or algebraic method or set builder method or property method or selection method where we'll actually define the rule. Okay, so we write it as A is equal to, what is this A? Set of vowels in English alphabets, right? So A is a set of vowels in English alphabet. How we write this one? In proper representation. We have already done this. A is equal to open the bracket, close the bracket. Okay, set of all x such that x is a vowel in English alphabet. So this is how you represent the rule method. Is it okay? Shall I continue? Then we go for different types of sets. Would like to continue? Different types of sets. Third heading, types and terms. First term here is element or what we call as object or what we call as member. Okay. When I talk about A, the set of vowels, it consists of A, E, I, O, N, U. We say that A is an element of capital A. What symbol we use? You know already, we have discussed. Epsilon, right? We use the symbol epsilon. So A belongs to capital A, right? This is actually the right presentation. You can please make a note. What are the alternatives we can have with respect to wrong presentations? See, I can write it as B does not belongs to A. Am I right? Okay. Or shall I write it like this? A belongs to A. This is complete a wrong presentation. See, this A is a set. This A is an element. This is complete a wrong. See, this one is right. See, A belongs to A. This one is right. But this is totally wrong. Okay. Okay. Shall I write this way? This is obviously wrong. So these are all the things you have to make a note of it. So this is wrong. This is right actually. This is right. Yes, B does not belongs to A is right. This is wrong. This is wrong. So this one is right. This is wrong presentation. This is wrong presentation. You may all expect this in the exams. Okay, so make yourself clear. So you say there this A belongs to capital A, and here you say B does not belongs to A. Is it okay? So this is about element. Like to go for the next content. Cardinal number. Second one, second term we use. Cardinal number. What do you mean by cardinal number? Cardinal number means actually you count it. Okay, you count it. That's what you call as cardinal number. The notation we use here is small n, usually small n only. So I'm talking about the second example. A is equal to A and A. Then what is the cardinal number of A? It has 5 elements, so 5. So we represent as n of A is equal to 5. Okay. This cardinal number n can never be negative. Please make a note, can never be negative. Asked once in the exam. It can be 0 and it can be positive. Again, if I say positive, it can be finite in nature and it can be infinite in nature. Okay. So generally, what is the nature of n? If it is asked, you write it as non-negative. Positive, negative, 0. You have learned this in your lower classes. I take the number line. This is 0, right? All the numbers falling to the right side of 0 is positive values. All these are negative values. No doubt in this. If this is negative, I'm going to talk about non-negative, which means not negative, which means I should not consider this one. Am I right? Which means I can consider 0 and positive values. So what is the nature of n here? It is non-negative. Usually we'll not write it as 0 and positive. So is there actually 0 and positive only, but we'll not say it as 0 and positive. We'll call it as non-negative number. N is a non-negative number. Not only here, in all the concepts, whenever I say it's a number, count of numbers, we'll say it's a non-negative in each. Is it okay? Okay, so non-negative. So when n happens to be 0, we call it as a null set. Okay. When n happens to be a finite number, we call it as a finite set. And when n happens to be an infinite number, infinite meaning what? There is no n defined, it goes on. Then we call it as a infinite set. Hope it is okay? Done. So this is first one, this is second one. In addition to that, we have defined third is null set. Okay. Fourth is finite set. Fifth is infinite set. Right? Okay. Finite. Here is one special case where you have only one element. N is equal to 1. In this case, you call it as, it's a special case. Okay. It's a special case. In this case, you call this as singleton set. That's it. Simple. What is singleton set? Okay. Shall I go for the sixth one? Sixth is actually a bigger illustration, like, because I need to go in detail. What are the things I'm going to discuss here is, I will talk about subset. Okay. Seventh, I will talk about proper subset. You can have all the headings noted because I'm going to go for an illustration now. Subset, proper subset. Okay. 8, superset. 9th, power set. I'll discuss this as a single set with the help of an illustration. Shall I take over? Shall I take over? Just listen, then I'll give some time for making a note of it. Let me take a set A, which consists 3 elements, 1, 2, and 3. You need not make a note of it. I'll give you time because this is somewhat an important concept. Let A consist of 3 elements, 1, 2, and 3. What is n of A? Okay, no doubt, right? Sure, because I have separated by commas. So 1 is there, 2 is there, and 3 is there. Okay. You're going to vary this n, which means what is the nature of n? You have to remember all these things. It's non-negative, which means it can be 0, can be 1, 2, up to 3 I'm going to vary. So vary n. So when I take n is equal to 0, what is n is equal to 0? Null set. So n is equal to 0 means we are talking about null set. Actually, what we are doing here is we are forming subsets. What do you mean by subsets? Means this is the main set. What you call this is a superset here. Okay, see, I have defined this one. What is a superset? The main set. Okay, it can be a universal set, it can be a sample space, anything. So I'm taking a set which is a superset. From this, I collect elements. That need not be the full complete set. It can be n is equal to 0, nothing, null set. Or it can be n is equal to 1. Or it can be n is equal to 2. Or it can be n is equal to 3. Please try to understand. I cannot take further 3. Because maximum 3 elements first. I cannot take further. But from when I can start? I can start from 0. So I'm going to vary n 0, 1, 2, and 3. So when I take 0, it's nothing but null set. When I take 1, yes, singleton, it can be any value, right? How many values present here? 1, 2, and 3. I can take any one element to form a singleton set. So I can take singleton 1 is a subset of A. Okay. I can take singleton 2 is a subset of A. Or I can take singleton 3, which is again a subset of. Likewise, I can do for n is equal to 2. Okay. N is equal to 2. I take it 2. Okay. Which 2s you can take? 1 and 2 I can take. Okay. Else I can take 2 and 3. Else I can take 3 and 1 or 1 and 3. 1 and 3 only because we go in order. Okay. 1 and 3. Okay. Thank you. N is equal to 3. I take all the 3. Okay. So I take the whole of the set A. This is how we form subsets. So this is nothing but formation of subsets. How you form the subsets? Formation of subsets. How you form the subsets? By varying n. For convenience sake, what I'm going to do here is I'm going to name it because each and every time I cannot have the full name. Let null set be null set itself. This is the representation we use. What is the sign called as? This sign. It's called as pi. You know this pi? This is also pi. This is also pi. This is small pi. This is capital pi. This is small a. This is capital A. Likewise, this is small pi and this is capital pi. This capital pi is represented for null set or y set or whatever it is. Okay. Okay. So here, for convenience sake, let me name this as A1. A1 is a singleton 1. I name this as A2, singleton 2. I name this as A3, singleton 3. Okay. I name this as A4, 1 and 2. What the subset A4 contains? 1 and 2. Okay. I name it as A5. I name this as A6. So A6 will contain 1 and 3. So this is just my naming only. It can be anything. I'm just naming for my convenience sake only. Yes. N is equal to 3, which is 1, 2, 3. I'll name it as A7. Actually, if you please make a note of it, A7 and A happens to be the same set, right? Okay. That's why you cannot call A7 as a proper subset. What do you mean by proper subset? It should be properly contained. Okay. So that's why I use the symbol. We use two symbols. For subset, we use this symbol. For proper subset, we'll use this symbol. Okay. Again, if you want to have more clarity on the symbols, leave off the subset symbol and all. You know this symbol? Okay, less than symbol. You know this symbol? Let me take x less than 2. What are the values it can be? And it should be a positive value. Okay, positive value. I'm leaving off 0. You can take x is equal to 1 only. If I take x less than or equal to 2, what values you can take here? 1 and 2. Because equal to sign is here. Likewise, I'm now talking about the symbol. See, if, you remember for union, actually we put it this way, but it's not U. The same way, we put it like a C, but it's not C. Okay, it's like elongated C. See, C, you write it like this, but we'll write this like some elongated C. Like okay, so when I write, so what are the sets we are talking here is A1. Please make a note. If I talk about A1, which symbol I can use? We have two symbols now. One is this symbol and one is this symbol. You're going to use this symbol or this symbol? It's a proper subset, so I can clearly use this symbol. See, here I am representing a superset A. Usually, superset is the main set, and all these A1, A2, A3 up to A7 are all subsets. And this subsets can be proper subsets. Okay, so when I talk about A1 is a proper subset. When I talk about null set, it's a proper subset only. Null set, always null set is a proper subset. Okay, so it's properly contained in A. How you read it? Properly contained in A. Okay. What about A2? It's properly contained in A. What about A3? It's properly contained in A. What is A4? Is proper subset, properly contained in A. What about A5? Properly contained in A. What about A6? It's properly sorry, not equal to. It's properly contained in A. What about A7? Which means it's a subset. Okay, so I need to write this as A7. This is subset of A. Okay, yeah. So you have to be very careful with these two symbols. So somewhat you may expect a small twist over here. You need to understand whether to use this symbol or this symbol. It's quite simple only. We have to understand. So this one thing. So we have discussed with respect to symbols. Sometimes for supersets, okay. See, when we are talking about this one, tell me which symbol you will put here. This one, this one, this one, or this one. This is one, this is two, this is three, this is four. Which symbol you will use here? Huh? You'll use first symbol. Am I right? Okay. I'll give some other example. Let me play with numbers. I'll use 10, dash, 9. Which symbol you use? It's quite easy only. Am I right? Greater than. Same like when I talk about A2, when I talk about A, which symbol I use? If I talk about A dash A2, which symbol I use? Just the reverse. This symbol. See, the same, see, 2 is less than 3. 3 is greater than 2. Both are same, right? The same thing happens here also. A2 is contained in A. How you read this is A2 is, okay, I'll write it over here because I need to keep it as a one pager. Let me write it over here. So how you represent here is, for example, I'm talking about A3. Okay. How you represent this one? A3. How you write in words? A3 is properly contained. It's a proper subset, right? It's properly contained in A. Is it okay? How you write over here? A7 is contained. See, the symbol is meant, is read as contained. Okay, this is properly contained. This is properly contained. When I write this one, it's contained. How we read epsilon? Does not belongs to and belongs to the same. So A7 is contained in A. Is it okay? The reverse. Can please make a note of it. If I'm talking about A contains A3, you read this as A is a superset, contains or properly contains A3. Is it okay? Can please make a note of it. Now, also I have to discuss about, so let me go for a small listing for convenience sake. What are the subsets we have defined? What are the subsets we have taken? Null set is a subset. Okay, A1, A2, A3, A4, A5, A6, and A7. Number of subsets. How many subsets you will have? 2 power n. This is the formula. Actually, how you arrive this formula, I'm not going to discuss now. I'm not going to derive it. Probably when we deal with permutation and combination, we'll discuss on this formula. So as of now, I'm not deviating much from the topic. Okay, definitely we'll discuss in future. So when we discuss about permutation and combination, I'll be discussing this formula. So it's 2 power n. What is n here? N is n of a. Okay, so 2 power 3, 8. Okay, one content. Second content with respect to proper subsets is. Can you help me out? Can you list the proper subsets? Null set is a proper subset. A1, A2, A3, A4, A5, and A6. You'll not get, sorry, A6. You'll not get A7 because A7 is not a proper subset. Yes, how many proper subsets are there? 1, 2, 3, 4, 5, 6, 7, 8. Here it is 1, 2, 3, 4, 5, 6, 7. No 8 because A7 is not present. So I can write this as 2 power n minus 1. Okay. 2 power n minus 1, which is 2 power n is 8 minus 1, 7. Is it okay? One more small content with respect to power set. How we define power set is power set itself is a set, okay, which consists of all subsets. Okay. The notation we use for power set is script P. You know how we write this A, script A, script B. Likewise, we write script P. See, when I talk about set of all subsets, for which superset you are talking about? See, I'm talking about A. A is my superset in my example. So you have to represent this as power set of A. If you're talking about N, you can say power set of N, script P of N. So I'm talking about A, so script P of A. So I have to open a bracket. See, we are mentioning clearly this is a set. Open a bracket, then is obviously close a bracket, separate by commas. What will be the elements inside? Set of all subsets. What are the subsets we have? See, null set, A1, A2, all the sets. So I have to write everything, which means I'm listing everything. Clear? It's a beautiful case form. A3, A4, A5, A6, A7 is present. See, we're talking about the subsets, not proper subsets. So when I say subsets, A7 will be automatically present. So I have to list A7 also. Clear up? Yes, now tell me, what is N of script P of A, which means cardinal number of power set, which means how many elements will be present in the power set? 8, which is following from the formula 2 power N. That's it. So one major concept over. So if you want to make a note of it, yes, you can please make a note of it. I'll keep it as a single pager. So we have gone till 9, right? Now let me continue with the next one. 10th heading, equal set, and 11th heading, equivalent set. Equal set and equivalent set. Sometimes we write in a fast mode, we'll get the spelling. If I slow down, I'm just wondering it's VA or VO. Okay. So equal set and equivalent set. Let me go for an example. A, let me have 1, 2, and 3. B, let me have A, B, and C. A and B are equal. No, they are not equal. So what do you mean by equal set? Means it need to have same elements. So what do you mean by equal sets? You need to have same elements. A and B equivalent are, yes, because same number of elements. When we say equivalent means same cardinal number. What do you mean by cardinal number? Number of elements present. It should have same cardinal number. So if I check with this A and B, I find that n of A is equal to n of B, both 3. So you call this as equivalent. For convenience sake, let me take a set C, which is having 3, 2, and 1. Okay. What about A and C now? See, 1 is present, yes, 1 is present. 2 is present, 2 is present. 3 is present, 3 is present. So A and B are both equal. You represent as A equal to B. See, when we say 2 equal to 2, 2 is a number and we say equal means is equal. When we say A equal to B, A is a set, B is a set, we have to say that A and B are equal sets. Okay, which means it has the same set of elements, maybe in a different order. And 11th one, equivalent. N of A and N of B are having same cardinal number. What about N of A and N of C? What about N of B and N of C? So A, B, and C, all the 3 are equivalent. Is it okay? The symbol we use for equivalent is like small curvy lines. Okay. And please make a note of it. For equal, we use just equal the symbol. For equivalent, we use small curvy lines. Okay. Shall I take over? Shall I go for the next content? 12th one. 12th one. Universal set 13th, sample space. 14th, complementary set. Complementary, you can call it as an operation or you can call it as a set. You need not worry about the terms. You can call it as an operation, complementary operation or complementary set. For example, if I say or if I take a set of English alphabets, is A a universal set? Yes, definitely. Because when you say universal, it's a complete whole set. You cannot you cannot even talk about one element extra. Okay. So we call this as set of English alphabets which has A to Z. You cannot call one element extra, so it's a whole set. You call it as universal set. When I say N, the set of natural numbers, yes, it's a universal set. Okay, because we are not confining a set, we are not giving any restrictions. Instead, if I talk about some set B, which consists of 1, 2, up to 1000, this is a sample space. Because we can talk about 1001. It's a natural number. See, this sample space I'm taking from a natural number only. It's a natural present, but in my discussion it's not present. Please understand. In my discussion is not present. In my discussion, I'm talking about the sample space, which I'm talking about only 1 to 1000 numbers. I'm not talking about number extra, but only this is confined for me. Whereas if you go for universal set, see, whether I talk about one number extra or not, N is a complete set. The whole set consists of all the natural numbers, so it becomes a universal set. There's a small difference. Okay? Why we need to discuss universal set and sample space is so very important because when we talk about complementary set, we need to know what are the other elements present. For example, again, if I go for the set A, for convenience sake, I have taken it's a set of English alphabets, right? So, set of English alphabets. It's a universal set. So, what I'm going to do here is for universal set, we use this representation. You remember when we did the Venn diagram? So, we use the capital U. So, this is a capital U. So hereafter, I'm not going to present this as U. So shall I write this as U? Actually, I should not write U, which means here in this case, for convenience sake, I'm writing. I cannot represent this as U because N is the universal thing. We give the name as N only. Okay. So yes. So I write U. U is a universal set of English alphabets. I name A, which is consisting of only vowels. What is A dash then? Take the help of the Venn diagram. I have this one. A, E, I, O, U. This is my A. So what is this? A dash, all the consonants. Am I right? What about here? This is B. Okay, B is the sample space. B is the sample space. Yes, please. If I talk about some C, which consists of 1 and 2 alone. What is C dash then? 3, 4, up to 3, 4, up to. You see, how to give some answer. Up to 1000. Why you say 1000? They have to please check the nature of C. What is a C? I have taken the C from B. I just took 1 and 2. See, we were working in a sequence. So your mind started working in a sequence. Okay. Actually, this is not maths. This is psychology. Okay, so usually this happens. See, when I was a student, I was also doing the same thing. Okay, so we were talking about P, which is a sample space. I was talking about from 1 to 1000 only. Automatically, I'm talking about C 1 and 2. Automatically, what happens here? C dash starts with 3, and your mind says it starts with us, ends with 1000. No, that's not happening. See, you're talking about complementary set of C. C consists of only 1 and 2, and from where C is taken, that should be noted. C is taken from the sample space B, then it stops at 1000. If it is not taken from the sample space and they say C is a natural number, that's why listing method is not always supporting us. Rule method will be helpful. If you write C in a rule method, how will you write it? Set of all x such that x is a natural number, okay, and x less than or equal to 2. See, now it's very clear. So you can write this C dash as 3, 4 was on infinite set. Okay. So your question may be like this. If C is 1 and 2, what is C dash? They'll not ask the values. They'll ask whether it's finite set or infinite set. So you have to be ready with all the terms. Okay. So now it's clear, right? So we have universal set, we have sample space and complementary. When you talk about complementary, you can take the complementary from universal set. If universal set is not given, only you have to go for sample space. It's very, very, very important. Okay. Only if universal set is not given, you will talk about the complementary sets from sample space. Okay. Yes, I can please make a note of 12, 13, and 14. What's the name numbering? 15th one. 15th one. Disjoint set. What do you mean by disjoint? No common. Okay. We can discuss in this way overlapping and non overlapping, right? Overlapping set and non overlapping set. We have discussed this with the help of Venn diagram already. This is the complete universal set of sample space. I have A and B overlaps, which means I'm getting some common elements. You call this as overlapping. When we talk about non overlapping, let me have in the same type. This is a universal set or sample space. We have A and we have B. There is no connection between A and B, which means no common elements. This is what we call as non-overlapping. With the help of operation on sets, if this is A and this is B, I can write A intersection B is equal to null set. Okay, right? There's no common elements. In this case, A intersection B has some common elements, so not equal to null set. Okay, then, right? Now, if it is only with respect to A and B, it's fine. If I have A, B, C, D, E, F, G, H, okay, what happens? In common, how you write or how you represent disjoint set or non-overlapping set here is, let me take a universal set or sample space. See, I'm talking about disjoint set alone. Okay, universal set. I cannot talk about sample space because I'm talking about the whole. Okay, this may be your A1, this may be your A2, this may be your A3, this may be your A4, A5, okay, A5, A6, A7, A8, A9, AN. Okay, if you please have a keen note, you will find that no sets are overlapping. Can you find it? See, for example, if I talk about A5 and A7, see, A5 is this area. Okay, what about A7? See, this area. See, it's not overlapping. Likewise, if you talk any set of sets, nothing will overlap. How do you present this one? See, we use the symbol intersection. So I'll write this as A1, intersection A2, intersection A3, all the intersections till AN is equal to null set. Or in short, see, you have done this one x1 plus x2 plus up to xn. You represent this with the symbol summation. Sum of x I is equal to 1 to n. Remember this type of a format? Now you can represent this disjoint set as intersection. Okay, this intersection is not this intersection. This is about the summation link. Intersection I is equal to 1 to n is equal to null set. Okay, this is also once asked in the exam. Yes, you can please make a note of it. It need not be up to finite number n. It can be any number of sets. You can just have up to infinity also. You can write, you can add this one also. I is equal to 1 to infinity. AI is equal to null set. It can be any number of sets. Need not be like finite number of sets. Okay. I take over online continuing. One more set we have with respect to ordered set or Cartesian set. The symbol we use it as multiplication symbol. Okay, but will not call this as multiplication symbol. We'll call this as Cartesian product. We call this as Cartesian product. Okay, fine. Let me go for example directly. A, which has A and B alone. Okay, please make a note. A has A and B alone. I take B, which has 1, 2, and 3. Okay, Cartesian product means, to say in a very simple manner, I take a graph sheet. Okay, x-axis, y-axis. You know how to write the coordinates? 1, 2, 3, etc. 5, 10, 15, etc. Okay. Point over here. What's this point? What's the coordinate of x and y? 2, 10. Am I right? How you write this 2? Place this over here. So 2, 10. This 2 is the x coordinate. This 10 is the y coordinate. Do not do anything with this 2. And this 2 will stand separated. This 10 will stand separated. That's what is Cartesian product is. Here, instead of x, instead of a, if I take this as x, instead of this one, if I take this as y, how do I represent it? X comma y. Just remember in that way. Now we are going to take the Cartesian product of order set. The representation used here is A cross B. How you read it? A Cartesian product B or A cross B. Okay. This is the symbol's name. This is the symbol's name. And this cross is how you read it. A cross B. Okay. So A cross B will be, okay, A cross B will be, see, it's named as order set. So ordering is important. You cannot change the order. If I write A cross B, it's A cross B only. If I write B cross B, it's B cross C. Okay. So I have to take with, or I have to start with A. To have A, I have to cross it with B, which means I can take A1, A2, A3, right in this form, coordinate form. So open the bracket. Actually, when I say A cross B, it's actually a set only. So I open a bracket, I close a bracket. Okay. So I write A comma 1 as a coordinate form. A comma 1, comma, A comma 2, A comma 3, right? Then I'll go with B now. B1, B2, B3. Yes. So B1, B2, and B3. Is it okay? Now tell me, how many elements are there? N of A cross B is equal to 1, 2, 3, 4, 5, 6. Actually, how we got the 6 is N of A into N of B. Number can be multiplied directly. Okay. N of A will have having 2 elements. N of B has 3 elements, so it's totally 6. You can please make a note of it. And why don't you try working B cross A? You please try working B cross A, and also you can try this one also. Yes, please. Manageable. Huh? Please try to understand the difference between null set, null set, and null set as a singleton one, as a singleton set. Actually, null set is not a singleton set. Null set is a member of the singleton set. See, what is this actually presentation is? Null set. This is also null set. What happens here? Null set is a member. Okay, null set is a member. Am I right? It's an element. For convenience sake, let me zoom this one. Let me name this one as A. Okay. I have in this angle. Here, this is an element of A. How shall I write it? Is it right? Yes, it's right. Okay. Now take A, which is containing only A. This A is different and this A is different. Now take A, which is containing only one member A. Okay. Yes. Can you vary the n and find the number of subsets here. You know how to form the subsets. Take n. What is n? What is n of A? 1. Vary n. So you have to vary n. How you vary n? N is equal to 0. N is equal to 1. N is equal to 0. What do you get? Null set. So null set by default it will be there. In whichever set you talk about, null set will be there. So null set is a default subset. Okay, I think I have this question. I have this question here. Null set is a default subset for all questions. So second one is answered. Okay, now come here. Is equal to 1. N is equal to 1. What is the subset here then? AR. No doubt here, right? Now, for convenience sake, here A is equal to containing null set as a member. Here A is equal to containing A as a member. If I replace this with null set, now this will look like this. Am I right? That's it. So this null set or pi is a element of A. Okay. We name this as a null set, but it's a element of A. We were talking about this power set. See this power set. Shall I write this power set like this? Shall I represent this A3 as belonging to script of A? Yes. Actually, A3 is a subset, but when I talk about power set itself is a set which contains only subsets. So I can write this as A3 belongs to, not contained in. I will not write contained in here. I'll write belongs to because this epsilon symbol is meant for representing the member. Okay, now come back here. So what's your first question? Does pi has a proper subset? Just now we were discussing. If I take this A to be singleton set containing pi as a member, does it has a proper subset? See, when n is equal to 0, is null set. When I take n is equal to 1, okay, it's null set containing, see, I have two elements here. Okay, what is the number of subsets here? What is the number of subsets here? 2 power n. N is 1 here. So 2 power 1. So 2. So I'm getting two subsets. What are the two subsets here? Null set is a subset and singleton set with null set as a member is a subset. See, I'm getting two. So this is different and this is different. You have to be very clear. Okay, it's clear now. Okay, so I have previous. Does null set has a proper subset? No. See, which is a proper subset? See, you cannot call this a proper subset. Right? This is a null set. This is not a proper subset. Okay, then is there any subset equal to a subset? Yes, there's actually the one which is not a proper subset. For example, A7 in our example, it was contained properly in A and a no was equal to also. So is there any subset equal to a subset? Yes. Third is clear. Shall I go for fourth one? Fourth. Is power set can be a null set? No. See, whenever I talk about 2, this fourth is automatically arise. Null set is a default subset, so power set can never be a null set. This is often repeated. All the 8 questions which I am discussing here on the board is often repeated question. Is power set can be a null set? No. Because whenever I talk about subsets, there is a subset. Okay. What is the power set of a null set? Just now we were discussing. This is a subset, right? So what is the power set of the null set? Pi and this one. Okay. Should I take over? So what is the power set of a null set? Power set of null set is equal to null set and this is the power set of a null set. What is this one? Singleton set with null set as the only element. Yes, did you try this one? A cross B is equal to B cross A. I was working with A cross B. Right? I was working with A cross B. I asked you to work with B cross A. What are the elements you got here? 1 comma A, 1 comma B. Okay. Then 2 comma A, 2 comma B. Then 3 comma A, 3 comma B. Totally how many? 6. Obviously this will be 2 into 3 into 2. Okay, 3 into 6. Okay. And if you check here, A cross B is not the same as B cross A. They both are not equal set but equivalent set. Right? So n of A cross B is equal to N of B cross A, which means A cross B is equivalent to B cross A but not equal. Right up? Okay. So seventh is okay. What about eighth one? Pi and this one are both same or no? This is a null set. This is a singleton set with null set as a member. So more or less is all occupying one single content only with respect to null set and except this one, seventh. I think it's clear. Okay. So almost major thing over. Probably I need to go for a new content. So what I'm going to do here is I'll just give some assignment. Can make a note of it. So what are the assignment is? You're going to work out this one. I'll be sharing the pages. You need not worry. I'll be sharing the pages. So this is page 2.4. Okay, so this page 2.4 points to ponder. It will be working. Okay, you'll be working this points to ponder. One second. 1, 2, and 3. We have 3 points to ponder means note. Okay. So this is on A minus B. So we have the operations A difference B. So you'll be working on what is A minus B in terms of other operation. And so you'll be working on these 3 operations. Then Venn diagram with different operations. So this is your assignment. You'll just try working. Anyway, I'll explain it to you. Okay. And addition theorem we have seen. Other laws we can just manage. Then simple problems I'll share. The complete set of problems I'll share. In the next class, I'll be discussing all the assignments, what we are doing, and the complete set of problems will be discussed. So, as I was discussing in the earlier session, all the problems you have to look out once before you come for the session, then only we can discuss in a better way. Okay. So, we have simple problems. We have like 21 questions, 20 questions, and word problems. We have 3 questions. So, totally 23 questions. Okay. So, I'll be sharing the pages now. So points to ponder. First one, points to ponder. Okay. Second one, I'll be sharing that Venn diagram. Okay. Venn diagram. I'll be sharing all the pages. And third one, simple problems, 20 problems, and word problems. So we have to discuss all these in the next class. I want you to be prepared with this. Just have a look. In case you find any difficulty or you don't understand, need not worry. I'll guide you. Okay. Thank you, Pa. Thanks.